Awesome. So here's how we will do this. What I'll do is I'll give you a systems design case. We will spend about first 10 minutes just flushing out all the requirements. So if you ask me questions, I will answer those questions. Anything that is missed out, I'm not going to answer those, and we will design the system based on what we have discovered. If that information is very critical, I will point it out. And then I would like each of you to like pitch in, like, what do you think the system would be and how it will be, and I will keep drawing over here. This helps with clarifying your thoughts and helping with the communication as well. So let's kick it off. So I don't know if everyone saw the email or not, but I attached a link which was basically designing a push notification system. So we're building something, designing something similar, but not quite. What we want to design is Apple push notification. So it's called APN. For folks who don't know what this is, give me one moment. So what this basically is there are two kinds of notifications that an application can build on the device, on the app. One is the local notification, meaning I code inside the application saying, hey, every day at 11 a.m., no matter who the user is, no matter what they're doing, there is no change, push this notification out. And it could be anything. If I have a game, hey, you have a game to complete, please come and play. So those are local notifications. There is a separate type of notification, which is remote notification. So let's say I have a big company which has like a lot of resources. I can start personalizing remote notifications, meaning if I detect sometime that, hey, this user it's quite likely that this user might actually fall off the wagon or they might uninstall the app, I can trigger a notification from my server side to the user's device by sending that notification. And it could be personalized. It could be saying, hey, Mono, why don't you take this new gift that we have only for you? And it could be only to me and maybe some subset of users who the app thinks is going to be. So what we are doing is the application is basically sending a notification to Apple push notification service, and then Apple push notification service delivers it to the device, right? So we are designing this Apple push notification service. So let's start with, does that make sense, or it's not clear? If something's not clear, just let me know and I can clarify it.
It's clear.
Awesome. Let's move forward. So ask me questions. There are two main type of definition requirements that you need. One is functional, and the others are non-functional, right? So functionals are basically, I'll give one example, like what is the size of data? That's functional. Non-functional are how reliable is the service, right? So reliability, consistency, those are part of non-functional. So let's start with the functional requirements. So ask me questions and I will start writing down the requirements over here.
Is this textual notifications, or are we going to include something like thumbnails or something?
Great question. So let's keep it textual. Next question.
So maybe the specifications weren't clear, but when, like, in which circumstances are these notifications pushed to, like, the user's less interaction with the app or stuff like that?
Yeah, so they could be, it could be something that is happening server side as opposed to the app. So it could be like, let's say, for example, the app was released on, let's say, 1st May, okay? And it was never updated after that. But on 1st of June, I'm trying to run a promotion. Now, because that promotion was not planned, it's not shipped with the app. So I can invoke a remote notification saying that, hey, here's the new promotion that I'm running, without re-shipping the entire binary. So these are just remote notifications that you can trigger anytime you want via a server, via a service. Does that make sense?
Yeah. Thank you.
So what's the time delay between what is there the time limit? Like if you send a notification that the user has to receive it within a certain amount of time?
That's an amazing question. So there is no guarantee. The guarantee that we as APN are providing is it will be delivered as soon as possible. But we can't guarantee a time because it could be possible that the user lost network, or they turned off their phone. So we can't guarantee how much time it will be. But if they are available, like if they are in network, then we'll deliver it immediately.
So it should be immediate. As long as there is network, it should be more or less instantaneous.
Exactly. Yep. Instantaneous if in network.
Do we want any kind of response?
That's another good question. So we do want to send out the response, and it could be a webhook. So it is up to the service that is pushing this, that is sending this notification to subscribe to that webhook. So there will be a webhook when delivered.
Acknowledge, you mean?
Acknowledge, yes.
So
not acknowledge, when delivered. So when the push notification service sends it successfully to the user opens it or not, that's not up to this service.
Right. But you want it to be reliable, right? You mean like
yes.
You want the server to know that it was sent to this user. Whether they open it or not is a separate question, right?
Exactly. So the non-functional will be yes, reliable. What next? What are we missing, or what do we need to know more?
Number of users, I guess. That
let's take the number of users that I would say 1 billion users. I think that was the latest stats. Yeah.
Okay.
And if no user activity is detected, do we resend the request or resend a push notification to the user?
Good question. No, it's one delivered once only.
Okay.
Is there a specific application which receives these notifications?
It could be any application. So I could deploy 1,000 applications, and each of them can have their own set of notifications that I could send. And I could send it via the same service. So I'll have one service, and each of them, like that one service will send one notification for all these 1,000 apps by sending it to Apple push notification. So it's per app, per user.
So would we care about the number of apps, or do we assume it's just one?
Yeah, we can just assume it's lots. I think there are what they say 100 million apps. But to be realistic, we don't have to plan for 100 million because not every app does this. So we can take like 20% apps are doing it. So let's say 20 million apps.
Can you explain 20 million apps and then 1 billion users relationship between these two?
So let's say I have one app, and let's say my app is downloaded by 1 million users. If I choose to deliver, so if I'm building that service, right? Let me just make a very simple diagram. So let's say this is, right? This is my service, and this is APN. And then there are this bunch of phones here. So if I have one app, and if I want to send one notification to 3 of these users, I have to send 3 notifications, the 3 requests to this APN, each with different token. So I would say a token, right? This token represents the device. Right? And then APN will basically take my take the notification I sent, and then it'll deliver it to the right right device. So it's this token, or the notification, is a tuple of notification ID, app ID, and device ID. Does that make sense?
Yes.
Okay.
By the notification ID, you mean the text or whatever that.
Yeah, you could assume it's generating a random GUID for each notification I'm trying to send. It could be that this notification ID is same across all 3, but the tuple itself is unique.
Yeah.
We would already have all the information regarding device ID with us.
Yes, you would.
So I'll have around 1 billion device IDs with me.
Yes, you can assume there's a service that will give you that information. Like you don't have to build the APN to do this mapping of device ID. Like you will have to handle this notification itself, but you don't have to worry about the internals of the device or anything. Or even like what like any metadata about the device, you can assume it's available to you.
Would our users be able to opt out of the notifications or limit the amount that they receive?
Yes. They can't. So those are 2 questions, and I will answer those. So yes, they can opt out. However, there is a caveat. Well, I would leave it up to you guys on how to design it. So let's touch that later on. I'll just mark it. The second is limit. So let's limit that one app can send 1 notification per second per device. So if I have a million users, I could send a million notifications, but 1 to each user within that second.
So it means the system should be extremely low latency.
Low latency is not a requirement. Low latency in which part? Like in delivering,
Pushing out, delivery, pushing out and then delivery.
So it should be. So we mentioned here it should be as instantaneous as possible.
Right.
But there is no measurement. Like we are not measuring like is it 10 milliseconds or 100 milliseconds. A second or 2 seconds might be okay.
Okay.
So here's one tip. Even though this number looks extremely large, and this number looks extremely large, and along with this, the worst case, yes, that 20 million apps sending out to 1 billion users, sending out basically 120 billion notifications is a lot, but that usually doesn't happen. So we can take more realistic, like this is where I would say, hey, what would be a realistic scenario? Like, are we talking about 20 million QPS, or are we talking about some thousands of QPS? Because how many notifications do you receive during the day? So that's where an estimation comes in, and that's where that kind of question pops out. So you want to make sure you clarify that. Otherwise, you will end up designing something that handles 20 billion QPS, which is your worst case, as opposed to something that handles maybe a few thousand QPS. And also in that case, the question would be, we did say that it should be reliable, but how reliable should it be? Can we say that it is available 99% of the time? Maybe for some apps, it's not available when the traffic is super high, the holiday season, for example. There are also other considerations, like 1 billion users are across the globe. So the service will be geo-replicated, right? So it's not necessary that it'll get overloaded in one specific area. Does that make sense? So like many times, like interviewers will give big numbers just to see if the problem, like if the interviewee is breaking it down. So we can solve this, let's say we just solve it for US, right? Then this 1 billion goes to 50% because there's kind of like a 50-50 split between iOS and users. So the population of US is 300 million. So we're talking about 150 million users technically for this country. Does that make sense? So
Yeah.
I would say,
So,
yeah.
Well, so yeah, you mentioned basically you were saying we don't need to design for the peak demand, which would be everything to everyone right away. So then you mentioned effectively that there's we want to really design for the average average demand. So what would that average be? A untypical number.
So that's a good question. So let's break it down. So we have 150 million US customers, and we are saying we have 20 million apps. Now, this is something that I'm pulling out of my hat. Like I don't have a real number for 20 million apps. I would say, okay, let's say on an average, there are 2 million US apps. Okay, this is completely a random number I made up so that we can work through the problem. And here's the thing. Even if we have 2 million apps, one app is usually not downloaded by 150 million, right? In Facebook, how many people download Facebook? It's the most downloaded app. We would say roughly about maybe 100 million. So Facebook is like the peak case, right? So we can start with that. So let's say 100 million. 100 million users. Right? And how often does Facebook send such a notification? Let's say they send per user, they probably send 1 or 2 a day. It's one per day would be maximum, because the more notification a user sends, an app sends, the user gets frustrated. So these are some, just the things to work through the problem so that you can break it down. And this is where realistic scenarios start popping up. Certain things that you can't predict is this number and this number, because this is something that, again, I made up. This is not a real requirement, but you can assume like, okay, I see 1 notification a day maybe, so it's like 1 notification per day, right? At this point, it might be better to involve the interviewer and ask, okay, then what is the realistic QPS we are looking at? Because the worst case, again, would be 100 million QPS. So at this point, I would say let's limit it to 50,000 QPS. This is not an average case. This would be the worst case. So let's design for something along these lines.
One question. How do you come up with these numbers? These I understand you kind of like made them up on the go, but a lot of the problems involve similar numbers. Calculating how many users there might be, and so on. How do you make sure that it's somewhat accurate and not totally I don't know.
Bull crap, yeah.
Yeah.
So that's a good question. So this 150 million, I worked in a digital ad company and we used it all the time. So I know that population of US is around 300 million. This was something that I knew.
Right.
Right. 1 billion users is, again, this was something that I just read somewhere. This is completely made up, but this, I believe, this should come from the interviewer. This is not something that you would argue or you would come up with. And you can involve the interviewer asking like, hey, 20 million apps I understand, but what is the realistic apps we have in US, right? And you can keep asking on that question. If they stick to 20 million, then stick to 20 million. Don't change that. The other number was this 100 million. Again, this was based on my understanding of, okay, we have 300 million people. Most of them are, there's a heavy population, which is like 35 plus. So I took like 50% out, 50 to 65% out, and that stood up with like 100 million. Again, it's a very rough ballpark, but I just took out like 65%, assuming there are kids. And then you have people who are above 35, 40 who don't use Facebook as much. It's usually the cream layer between 18 to 35 who use that, right? So that's how I came up with that number. Again, you'll probably not be accurate, but that's how I pulled that number. This 50,000 QPS, this is, again, that should come from the interviewer. But the interviewer will not, again, it depends on the levels you're interviewing at. If you are under like 3 years or 5 years, they'll probably just spoon feed it to you because you're not expected to drill this down. But if you are interviewing for like senior or staff or principal, they will expect you to break this problem down, because in your daily job, this is how you will be asked, like, hey, we want to design a system like this. How do we do that, right? A PM will give you these numbers, and you are supposed to, as an engineer, work through this and figure out this QPS. So, but you have to ask the interviewer, you have to involve them in the conversation that, hey, for this system, what is the QPS that I can assume, so that it's not like, we are designing for 100 million QPS, something more realistic. Does that help?
Yeah, makes sense. Thank you.
Okay, so we have some rough idea of what system we are building. We want it to be highly reliable. Maybe you guys were going to ask me, but it needs to be eventually consistent. For folks who don't know what this means, is basically you have a banking application. Take an example of banking application, and take an example of something like Facebook or Twitter. On banking application, if I'm saying, hey, transfer this money from my account to XYZ person's account, the result has to be consistent. Like, if the money is taken from my account, it better show me that it's taken from my account. If there shouldn't be a case where I refresh and it shows the money, and then next time I refresh, it says the money is gone, right? It has to be consistent. The transaction has to complete. And eventually consistent means, let's say I have a few followers on my Twitter feed, and I posted something. They don't see it right away, but some people see it in a minute, other people see it in 3 minutes. That's completely okay, because it's not a financial or a more important transaction. So eventually consistent means it will be consistent eventually at some point in time. So we want reliable, we want eventually consistent. What else are we missing? We spoke about speed. We want instantaneous in receiving. Okay, I think we have pretty much everything. Do you guys agree, or do you think we're missing something?
These notifications, are they timed, or do they need some action within, like, is it something about sale, flash sale kind of a thing, or something which needs to be acknowledged or has to be acted upon immediately? Because in that sense, eventually consistent wouldn't make sense, right?
That's a good point. So let's say we say that the delivery is within few minutes, and that few minutes can be 0 to 3, nothing more than that. but we don't guarantee that it will be, under worst case, when the whole system goes down or there's a peak load, we don't guarantee that it will be instantaneous, right? Because they're not meant for flash sales. The app deciding to use it for flash sale, that is an app's decision. That is not a decision by the team that is designing the service. It's just meant to send it. It's just meant for another way to send notifications, if that makes sense.
So eventually consistent means like eventually all the users should be getting the notification.
Sorry, 1 minute. Sorry, my kid was wrong. Sorry, what did you guys say?
Yeah, so eventually consistent means eventually all the users will be getting the notification. Is that what we mean by eventually consistent?
Yes, exactly. Like once the notification is sent to this service, the service will send it to the user's device. If everything goes well, it will be instantaneous. If not, then it will be within 0 to 3 minutes.
And do we need to take care about order of notifications?
Yes.
So let's say my first notification isn't delivered on time, but the second notification should wait for the first notification to be delivered.
That is a good point. No, not in that way. But if again, like I said, one app sends one notification per day. But if let's say I sent 2 notifications, the first notification does not reach because the user was not there, and it goes back into the queue or whatever we are designing. The second notification, when it comes out, if you send that and the user is available, it's fine if it is delivered. The order does not matter in that sense. But in general, like I wouldn't want where I send 2 notifications and they're just randomly shuffled and sent without any priority, right? There is a priority in the beginning, but once it's retried and if it can't make it, the priority might change.
So there's order in sending, but no order in receiving.
Yeah, it's not a guaranteed order because things can go wrong, right?
Sure.
Yeah. Okay, so let's start with a basic designing. Again, this basic designing, I want to go over that first because if again you're between you have around 3 years of experience, this is something that they might expect. For 5 year plus, you definitely expected to do this and a little bit more. So let's do a very basic design. Let's start with, where do we start with? What would we have in the beginning? So now we are designing something like APN, right? We're designing exactly APN. So who wants to kick it off? Like what would be the receiving side?
So
It would be-
we may, sorry. So we probably need to start with the APIs that the client needs to use to send these notifications to whatever structure that we store the notifications in. Okay.
So let's define one API, which is just pushing the notification, and for now, and then we'll design the webhook later on. Okay. So what would this look like? It doesn't need to be very RESTful API or anything. What I would like to know is what HTTP method it is, and what is the body and the header. Just the basics, just the main stuff. Like what would it include?
So it'll be an HTTP post request with the notification ID, which is generated by an application. And given that the device ID can be generated from Apple's on some other system, we ignore that. And then time it needs to be sent out. And let's see. If there's any additional message, I don't know, any other payload that we want to send along with the request.
Okay, awesome. So we have payload. So this will be the part of the body.
Yeah.
All of this. Okay. How about so this is something that I would add because you did mention it. The header will have a token, which is basically your device ID, and it's basically some token representing device ID. So I'll just put it as device ID underscore app ID. Okay. Okay. So awesome. So we have this API service now. Where do I send this API to?
So the APN service should have some way of accepting these requests and then persisting this data. So it could be a simple web server that could accept these HTTP requests and then just persist to a queue because we want something like first in, first out data structure.
Okay. Okay, so you have your messages inside the queue. Okay.
Yeah. I'm guessing we're just starting with the basic design without going to replication and things like that. Okay.
Absolutely.
And then let's say we have another server method that processes these messages in the queue.
Okay. Oops, sorry. Okay, so we are processing. So we are. What are we doing in this process?
Essentially, looking at the body of the message and then doing some kind of deconstruction to send to the accurate user of an iPhone.
Okay, so let's say I say we deserialize the token, get device ID, send message, send payload.
Yeah.
Does that sound something? Yeah. Okay. Okay. And I would say, let's say we have phones here. And this would basically say, okay. So this is a very simple design for folks who are, again, this is the distributed queue is something that I have got questions on before. So think of this message queue. This is basically a distributed queue. What this is when, if you remember from your algorithms and data structures, you have this queues, which are basically FIFOs. Distributed queue is exactly that, but think of it as it's a big queue. It's distributed in the cloud, and you can access this queue across different machines. So if I have like 5 machines, if I have this multiple different processes running, each of them can access the queue, and it's reliable and consistent, meaning if there's message 1 is pulled out from the queue, no other process will see that message 1. So that is what a distributed queue is. If you want to look this up, look up Amazon SQS. This will clarify certain things. But again, you don't have to know this concept. You can just mention distributed message queue. Knowing how it works will help you carry the conversation in case if it gets into that. But because we are limiting the systems design to this APN, 9 out of 10 times they wouldn't go into SQS or distributed queue. Awesome. So we have this service that seems to be functioning. Now let's talk about failure modes. How would we handle different failure modes? And this is exactly what you mentioned, which was like replication and stuff. So let's dive deeper.
We need to have a mechanism where undelivered notification gets into some kind of a temporary queue, which which when the device gets, let's say, powered back on or gets into the network, those push needs to be sent to them again.
Okay, so how do you want to design that? So let me write undelivered. How do you want to design that?
So from this message queue, it can go to a letter queue, maybe temporary
Okay.
queue,
Okay.
which then which has a time where those messages get expired. Those notifications gets expired after a certain while
Okay.
if the device is still not in network. Some kind of a background job then runs and tries to attempt to push them to the device.
Got it. So let me clarify this. So this process, this process is basically pulling out the message. It's trying to deliver it, and if it cannot deliver it, it's putting it into this queue. Correct?
That's right.
Okay. Now we have now we have two queues to maintain. So we have this another queue that we are looking at, which is the undelivered queue. What manages this queue?
So when you receive an ACK from the phone, you remove things from that queue.
But something has to do that. Is it the same process, or are we building a different set of
Oh.
processes that do with that? We could go either way. I'm just asking for clarification.
Since it does the same thing, process block, if scaled higher, once the resources are free, it can also push messages from the undelivered queue.
Got it. So
because it does the same thing.
Fair enough. So I understand that, but there are two things here, right? One is separation of concern. One is, so yes, I agree that the process is doing the same thing. However, the one thing that comes to my mind is something has to tell the process that the device is online, right? So either the process is checking that, or the device is connecting to this process, which means that this process will need some sort of front end so it can connect to it, right? Or maybe this is the front end, I don't know. Does that make sense? So let's say this connection was severed. This device was not online. The device comes online, right? There are two ways the process can know that this device is online. Either the process is polling a few seconds, or the device tries to connect to the process. Right? So now the process is doing.
That's right. The device, it makes more sense for a device to actually call and see if the device has any notifications or not.
Got it. Got it. Now, okay, so let's say device, and we'll come back to this because there's one issue we haven't resolved in this. Device connects. Process pulls. Now, one question I have is, how does, so you have this is a queue, right? This is an undelivered queue. How are we partitioning this queue? Is this queue, how are these messages sent into the queue? And what I mean by partition is, let's say I have 3 phones. Are all the messages for this 3 phones inside one queue? Or do we have different queues for each phone? Because you wouldn't know if all of them are in the same queue, you wouldn't know if this is for phone 1 or this is for phone 2, phone 3. It could be in any order, right? Same for the undelivered queue. Like, let's say if all 3 phones are unavailable, then it is quite likely all the messages for these phones are inside this queue. So if only one of them comes back online, how do I make sure that I'm only retrying the notifications meant for that phone?
Yeah, I don't think you want a queue in that case.
Mm.
You could just append all the messages and just store it in a table or some kind of whatever, some not necessarily a queue store, a queue. It's because now you have a whole bunch of messages for a phone that are piled up. And so when that phone comes back online, I could just go back and look at that. I'll get all that process would know, okay, this phone came back online, and I could just look up and say, well, I have this many messages that are pending that need to be sent to that phone.
Okay, so we want to change this to a table, right? Okay.
Some data store of some type.
Some data store, yeah. Store by device. Do other people have thoughts on this? Okay.
You can have,
Mhm.
sorry, I mean, I assume this every device has its own queue in this table.
You mean in this table or in this queue?
Yeah. No, in the undelivered table.
I see. Yes. So it could be different ways where you could store the notification payload in some blob or something, and then you reference it in this storage saying that this device has this pending notifications. You fetch it and then you process them.
Ordered by send time or something like that.
Exactly. It could be ordered by send. It could be a tuple of device ID and send time. Device ID. Sorry, it would be basically. I think it would be a tuple of something like this. Maybe time would be appended to it, but something along those lines. Okay, so we have this service. So far, it seems to be fine. Let's talk about replication. How do we? What are the possible places where this?
Well, actually, let me ask one question. So there's another way to look at this: is that do we really need a message queue, right? Because I could just say store it into the same table with a count of like how many times I retried, right? Or something like that, or whatever, or some timeout period of like, okay, after a certain amount of time, I'm just not going to send it anymore, right? And that process could effectively, so you couldn't theoretically just eliminate the message queue, push everything into this store and say, well, whatever devices are online, I just send that out or in the order that they appear in the store. Do you see what I'm saying?
I think the problem with this is that the device will not send you a notification that it came online if it's already online.
Well, not necessarily, but you just try and send it.
Oh,
Same thing with the message queue.
Okay.
So let me ask. I need one clarification, right? So let's say we store the information here instead of going to the message queue. The process wakes up, or I'm assuming it polls every few moments that, hey, is there a new notification? How does it poll? Like, does it poll by device ID or does it poll by time? Like, because something has to replicate the FIFO nature, right? Somehow something has to replicate the FIFO nature. Or else, or are you saying, or you will have to go through each device and say, do you have a notification for this? Do you have a notification for this? Which seems...
I could just say query order by, the device ID, comma, whatever, device ID and time or something, or time and device ID, whatever priority I want to use, right?
You definitely could, but the process, so this requirements that we have made here, right, which is one app, one notification device, those are not enforced. Those are the soft requirements as opposed to hard requirements. So the process technically doesn't know that there's a constraint or anything. So if, let's say, 300 million phones are online, it will have to run that query 300 million times, right?
Not necessarily.
Okay.
Not necessarily. What I could do is that I run the query, let's say I run it every second or whatever, some interval, right? And every second, I could get a list of however many are there at that time. It
Mhm.
could be 300 million, it could be 100, it could be 10,000, whatever. Actually, it's more like 50,000 is what
50,000, yes, yes.
it's more likely 50,000. So I'd run this query and I would get nominally 50,000 or less, right?
Okay,
So I could then just use that 50,000 and ordered by the right criteria, by meaning like the send time or whatever. Let's just say send time, right?
Mhm, mhm.
And then just try and send out each one in that order, right? And if it fails, I don't mark it, I don't delete it. I just I leave it there. But then I would probably do some kind of cleanup, because I think somebody else mentioned it's like, well, say it's been a day or 2 days or a week or some retention time.
Mhm.
We just delete it, or put it, or just log somewhere that, hey, we tried to send this thing, but it was not possible, whatever, for tracking purposes.
Got it.
We might want that metric.
Okay, fair enough. So I now a follow-up question I had is how many processes are doing this? Like, is this like one process waking up every second saying, give me 50,000 rows, or give me 1 second of rows, and it's probably 50,000? And how is that being parallelized? Because sending 50,000 notifications might take a little bit of time. And if there's a catch up to do, it might take even more time, right? So I'm assuming you would have more processes running, which could be parallelized in the queue because each one of them wakes up and gets the first item. How do we
Sure.
do that in the data store?
Well, in the data store, I could partition it, right?
Okay.
So there's a lot of different ways I could partition that data store.
Mhm.
I could partition it geographically. I could partition it by device ID. I could partition it by, I don't know, but choose some suitable partition, right? Because we know that each device is not going to get a million. Let's say we partition by device ID or group of, some subset of device IDs, right?
Mhm.
Each device is not going to get more than one a second, right? So if I take the theoretical maximum and say, okay, you said there's 50,000 at any one. Well, even still, there's only 50,000, right, per second, right, that I have to send. That's just the maximum that would, well, 50,000. Yeah, that is the maximum I would have to send out. So even if I had, let's say I had 10 processes or however many processes, it doesn't matter. I could partition the data store by device ID, through a hash or whatever. It doesn't really matter. And I could just each of the processes that looks at it, I could just query by that partition and say, well, give me all the ones that I need to send,
I see.
right? And send those out.
Got it. So you would basically partition or shard, and then you would have each process look at very specific partitions, saying that I want the device IDs that you own. I don't want everything. You're not running a query across all of them. You're running a query across that partition.
One way to scale it, yeah.
Okay. So run query. Anyone else have thoughts on this?
Isn't that more load on the database though? Even though you're starting by the device ID, now you're going to have to read a lot of rows. And then once you're done processing, you're going to have to go back into the database and then update those rows, rather than just popping out of the queue where you're not actually reading all the elements or more than one, and then processing it and then coming back and then, processing the next.
Well, it kind of doesn't make any difference. You're going to do that if for everything that's pended in that, that wasn't sent out of the queue anyway, right? So you're going to have that problem either way. The other thing is that you don't need to use a relational database. You could use any number of other scalable data stores again, actually, we just use a simple data store that is highly scalable, right? There are many, many types of those that are capable of doing that.
More than speed, my concern is actually the tight coupling between the process and the partition itself. Because let's say if I'm saying, let's say I have two partitions, right? And which means I have to have some sort of mapping of partition to the process, because from what I understood, a process is asking a partition to give me all the device notification for group by device ID so that I can send it to them. So this mapping becomes a tight coupling. So every time I add a new shard, I have to make sure that there is a process for it. And my replication also goes by process, because each of them could go down, and then that shard is left alone with no process doing it, right?
So yeah, that's a fair point. But look at what you have right now. Let's say you have the queue. You say that you have a problem and you can't send anything, right? And everything gets pended into this device store. You're back to the same problem, right?
I think the nice thing about using the queue versus having the data store is, this is just making an assumption, but there's probably more devices that are connected at any point in time versus the number of devices that are coming online. So being able to pick up messages from the queue and send those along to the devices as soon as possible versus needing to constantly pull against the process and then transitively to the data store, it's probably going to be a bit more cost efficient.
Possibly, but didn't we say that we had 50,000 per second?
We did. It is a 50,000 QPS, but of those 50, let's assume it's across all the phones, all the apps. The chances of the number of apps going, I'm not saying the data store is not required. In my opinion, queue and store both are required. The store could hold the undelivered messages because, as Kevin mentioned, the number of messages not being delivered because phones are out of coverage will be lower. We can make that fair assumption, lower than number of messages that would be delivered. So running, and I think if it were up to me, it would be a separate process that would pull this and send that information to the phones. You can have a single connection to one front end from the phone to this entire APN, but there would be a separate process that would work with this data store. So separation of concerns. This is just looking for that specific notifications which are not delivered. That's just one. That's one way it would work. Yeah, go ahead.
So how about if when a message cannot be delivered, we just put it at the end of the queue?
Excellent. I love that. Anyone have thoughts on that?
Then that would, if there are a lot of items in the queue, then you're putting it in the end of the queue, then that notification from that particular app cannot be completed in the given time, right? I mean, the latency for that app's notification to go out to all of its users will be delayed just because you missed this one notification to one user, right?
So that's a very good point, because because we did mention over here saying that it will be instantaneous if in network, and we will retry after a few seconds, right? So if the phone is not in network, this requirement does not need to be fulfilled, right?
And it's eventually consistent anyway.
Exactly.
But overcrowding could be a thing, right? Like if there's a lot of devices offline due to, let's say, an outage, network outage, then there are tons of messages undelivered. Then
could be, but if you consider entire US for now, you would technically partition this geographically. So I would have some in data center of US West, US Central, US East Coast, also in multiple different data centers. So let's assume AT&T just went out in one state. Even then, that would be only that data center that would get backed up, not everything else.
I see.
And that would not be that it would be 150 million divided by 50 states, right? So assume equal distribution for now. Cool. We have 2 more minutes. How would we how are we handling this process? What the key question I had was, let's say I have a few processes running. The process pulls it out from the queue and the process dies. What happens? Where does the message go?
So the message should not be removed until the process is successfully, well, no, well, in that case, some other process could pick it up. I guess once the process picks it up and then successfully processes it, then I don't know, some kind of notification status needs to be stored somewhere. That way, we know that this message has not been lost during processing.
Okay.
Is there some sort of commit API with the queue so that you can tell the message queue when that you're in the middle of processing a message, but you haven't completed it until something has happened?
That is an excellent point, because message queue do have something like that. But just mentioning something, saying that, hey, if there's a commit API to the queue, we can use that, makes the problem much easier. So just an implementation level detail. Queues, you do have an option of disappearing the message for a set amount of time. You can say that, hey, I want to dequeue this, but I don't want to remove it. I want you to disappear this message for 5 minutes. If I don't report back to delete this, you can make this appear again in the queue. So it basically enqueues that message again. So that's exactly your commit API. So something like,
sorry, so it adds it to the end. It does not reappear it in the current position.
But it depends. Different queues have different implementations. From what I remember, Amazon puts it at the back of the queue. But
you are violating that requirement if the device is online, your process was offline, and you are not delivering it on time.
That is true. That is true. But we did. I did mention it is 0 to 3 minutes.
Okay.
Right. So we just have to make sure that it is it comes back in it is back in 3 minutes. But that's a very good point, because if it doesn't come back in 3 minutes, like let's say for 3 minutes all there is a crash in each of the process, the queue, it's just backing it up, right? So what do you guys think? What would be a way to solve that? Let's make a quick discussion on that, because we are already over time.
Just have another process?
But let's say yes, but let's say this message was pulled out and it failed, and the queue says that I will push this message back into the queue, right, after 2 minutes or after 1 minute. And let's say the code that was pushed out is just causing all the processes to just die. There's a crash in the process. It's just dying of null exception, null pointer exception. So the processes are coming back up. They're pulling the queue, but they keep on dying. So the queue, all the messages are just backing up again and again, right? And they're just going to the back of the queue until that process error is fixed. But once it is fixed, you have no control that this message might be at the end of the queue or it might be at the beginning, because your queue has completely been rotated with all the messages. Any thoughts on that?
Our sincere apologies.
That's a
So
good answer.
in all honesty, this is why I avoid queues.
Got it. Is it because they dequeue it to the end, or because they are unreliable?
Well, it's more often than not, so the fundamental nature of the queue is is sequential, right? Because you need something that's sequential, right?
Mhm.
You could implement that in a number of different ways, right? You don't fundamentally need a queue to do that, right?
Mhm.
There's any number of ways to implement that. And the challenge I've always found is that if you use a queue that somebody else has implemented, like SQS or something like that, and you use it for something that is that has a number of constraints that you have. Okay, I want this reliability, I want this, I want this, I want this, and I want all these other things. It just becomes more work than it's worth. In just my opinion, right?
No, completely fair. But let's forget about using someone else's queue. My point is more around like something that you mentioned, that you could implement something like queue in many different ways, right? So the base concept or fundamental remains the same, that there is some form of a queue. It could be a custom implemented queue based on this very specific scenario, right?
A table with a sorted query is the same thing, right?
Right, right.
So how about, like, going back, how about if we just have a checker that checks if the process is online, and if the process is not online, we stop pulling from the queue?
Excellent. So you would have something here, a watchdog rather, which or a zookeeper or something like that, which pulls for this queues. And if what happens if the process keeps on dying?
Just stop pulling from the queue until the process is back up. So basically the queue does not get like pushed to the back. Like the order queue stays the same.
Okay. Cool. I think we have run out of time to understand this because the process is the one pulling from the queue. So I don't know how you would lock the queue.
Yeah, that's what I was thinking. I was thinking that probably pulling from the queue should be done by the watchdog if the process is online.
See, the fundamental problem is that you want a transactional queue, right? And that's you're trying to implement a transaction in a queue.
Yeah, you kind of need a way to say if this item is done processing and if it has been delivered, according to Madhu's point. Yeah, so this includes a transaction, which will be the same as the database if it was ordered by I don't know, some notification ID or timestamp or something like that.
Got it.
We do have acknowledgements, like for example, in Kafka, we do have acts provided by the process, whether that particular message has been processed or not.
Cool. Okay.
Also, sorry, does it make sense to not push the message on the back of the same message queue and push it at the end of a separate message queue? Because in case like there's a lot of failures happening and I'm keeping pushing my messages towards the end of my message queue, the new messages which are coming will also get delayed. Sorry.
Right. So the problem happens, it goes back to what Madhu was initially trying to solve with the data store, which is you have another queue and which is undelivered messages. And now when you don't know why it's undelivered, so you'll have to have the process rotate through two queues, and that just never keeps on ending, right? So, or you just keep on saying that, okay, everything in the undelivered just keeps on re-queuing. So if it is undelivered because the device is offline, bad luck, like it will get delivered when it comes back into the queue as opposed to when the device comes online. Does that make sense?
See, the reason I mentioned that is like, if you look at how queues are actually implemented, you look at any of them, they basically just have a data store back there and they just, order it. And that's all they do, really. There's nothing more than that. So what I tended to do is like, because rather than depending on the semantics of a queue that somebody has already implemented, use a data store and implement whatever semantics you want, meaning that you can get whatever transaction you want to implement just sort of been my approach to it, right? Because I tend to define that every time, I've known a number of people that always go down that path of like, okay, let's try a queue. And then say, okay, we always get into this funny problem of like, well, what if this happens? Well, what if that happens? What if that happens? And it comes down to, well, to achieve, if you wanted just a simple case and I don't really care about reliability and I just want to pull something off and just send it out, queue is great for that because you don't need that transaction, right? But now when you start introducing a transaction, meaning I acted on it, I want it to go out and I want it removed, then you get into all these, okay, then you got to add something to, in the case that this failed and then that failed and that failed, and then that's just sort of been, and then I kind of come back, it's like, well, why don't I just come up with a data store and just, scale that, right? And there are definitely ways to scale it. That's, I've definitely scaled things that way, and just sort of been my, it's probably a preference thing, right? Whatever. But it's like, because the queue is not fundamentally transactional, right? I mean, some could be, and you could have that, but you want some kind of two-phase commit, in that queue, and it may or may not support that. Do you see what I'm saying?
No, that makes sense. The only thing I was pointing towards with the data store was basically this mapping. So the decoupling was what I was, which I felt was that the process and the shard itself are tightly coupled. And I agree with you, like, there are ways to decouple that as well. But yeah, I agree. Like, we can use a data store. There are ways to solve it with the queue as well. But again, if we then rely on the semantics of a particular cloud provider. Cool. We are over time, so thank you everyone for joining. This was a fun discussion. Next week we'll probably do some algorithm data structures. If you guys have thoughts on what you would like to see, let me know. I'm happy to accommodate that, or I'll pick a topic of my choice.
Thank you so much.
Thank you. Have a good night, guys.
Thanks.
Thank you.